Our next panel, called The Road to U.S. Biomanufacturing Leadership, will be moderated by Vivek Chilukuri, Fellow at the Center for a New American Security. Please welcome our distinguished panelists, Dr. Robert Conrado, Chief Technology Officer at LanzaTech, Deepti Tanjore, Director of the Biofuels and Bioproducts Process Development Unit at Lawrence Berkeley National Laboratory, and Edward Shenderovich, co-founder and CEO of Synonym.
Great. We good to go? Okay. Hello, everybody. Thanks for joining us. My name is Vivek Chilukuri. I lead the Technology National Security Program at CNAS, a bipartisan think tank here in DC. I want to first congratulate the Commission on their terrific report and this accomplishment that they've spent 2 years doing a lot of really incredible work on. And I have to say, I can't imagine when they were working on this report for the last 2 years that it would have landed at a moment of, shall we say, historic dynamism in the market. But in some ways, I think it's actually very fitting because this moment has drawn increased attention, perhaps more than we've seen in many, many years, on the imperative of American economic security, energy security, resilient supply chains, and of course, biotechnology and biomanufacturing specifically applies to all of these things. And Washington is just beginning to wake up to the potential of biotechnology to help address all of these things. We woke up a few years ago and realized that we weren't making any of the semiconductors that we needed, but we haven't paid nearly enough attention to the fact that we aren't making the pharmaceuticals, the chemicals, the key inputs for a lot of our military applications that we need as well. And of course, this commission and its report land at a perfect time to help galvanize this conversation, and they've laid out a pretty incredible roadmap for the way forward. And I think the question for policymakers is whether they're going to follow it. And we have an excellent panel of experts from the research and industry community to help unpack the opportunity of biomanufacturing and also dig into some of the challenges. So just to jump right in, I'd like to invite each of our three panelists to introduce themselves and also to do two things: to situate themselves in the broader biotech and biomanufacturing ecosystem, and also to give us one thing they're most optimistic and hopeful for in the biorevolution and biomanufacturing. So let's start with Deepti, please. Thank you.
Good morning, everyone. Can you hear me?
Yeah.
So yes, my name is Deepti Tanjore. I'm the Director of Advanced Biofuels and Bioproducts Process Development Unit, also known as the ABPDU. Yes, both the name and acronym are a mouthful. So you can think of us as the scale-up facility, Department of Energy funded at Berkeley Lab. What I'm most excited about is that biotechnology is still kind of perceived as a science in the lab with scientists and pipettes, but I think we are going to transition that phase very quickly into manufacturing, as Vivek has mentioned, and see products in the real world. Yeah, so they're very excited about that.
I'm Edward Shenderovich. I'm the CEO of a company called Synonym, and we deliver infrastructure for the bioeconomy. I came to the space as a venture capitalist, and I started looking at companies in the synthetic biology space, especially food-related and bioindustrial applications. And I thought, why aren't these products being adopted faster? Why aren't we all using products of biotechnology when the promise of it is so exciting? And there's this talk of the great reformulation. Large companies are talking about reformulating their supply chains, using new ingredients. And we feel that this should be happening faster, and that requires a lot of work. Infrastructure on the digital side, infrastructure from a human resources perspective, and of course physical infrastructure for production of these materials. And I'm really excited about the promise. I'm really thankful to the Commission for putting together the report. It's phenomenal. It is a watershed moment for the industry. I think that we should recognize that bioproducts are ubiquitous already. Those who eat cheese consume a product of biotechnology. It's a product of natural fermentation, but then we're using fermentation to produce rennet. So we should let the world know how prevalent biotechnology already is and how much more prevalent it can be.
Great. Robert, please.
Hi, and good morning. Robert Conrado, Chief Technology Officer at LanzaTech. We are a Chicago-based, publicly traded carbon management company. And we've both been an innovation hub for the last 2 decades and also delivering solutions in the marketplace with our commercial plants operating globally. I am most excited right now about the opportunity to deliver both on the lower costs that everybody has been expecting and also the higher performance that we can get out of biotechnology. It's a time when we are seeing the exponential growth in so many technologies that are coming together at the same time, and we need to force ourselves to stop thinking linearly, but recognize the exponential curve that these technologies are on, both in terms of performance and cost, so we can get ahead, maintain our competitive advantage, and deliver all those benefits that.
Great. And Robert, let me follow up and just ask you maybe a scene-setting question to get us started, which is, can you just give us a sense of the current state of biomanufacturing in the United States, and what are some of the key headwinds that you as someone who's working directly in this field see for this sector to realize the potential that the Commission envisions in this report?
Thanks. In many ways, the challenges are similar to those facing manufacturing in general. Uncertainty in the marketplace, investors very much focused on delivering near-term returns, a real focus on costs rather than capabilities and performance. And I think we need to do a better job, one, delivering on those promises and executing, but also selling those benefits to cost and performance. And I think that's where biotechnology has some really unique advantages to deliver on higher performance, better attributes, whether it's the capabilities of the product, or what downstream applications it enables, or how you're able to simplify supply chains through the method of manufacture, the feedstocks you use. But we really need to focus right now on kind of delivering on the core benefits of creating jobs, reducing costs, and keep reminding people of the long-term vision.
Great. Thanks, Robert. And others should feel free to jump in. And in that spirit, Edward, we were talking backstage. Go ahead.
Yeah, if I can say something to that respect. I think the state of U.S. biomanufacturing right now is pretty bleak. We have phenomenal technology. This is where U.S. excels. We have great lab capabilities. We even have great scale-up capabilities with ABPDU, world's leading. We don't have a single multi-purpose demo plant in the U.S. And that means that we cannot scale up biotechnological products. We can't scale up bioindustrials to commercial scale in the U.S. And this is something that needs to be remedied.
Yeah, no, I agree. Deepti, let me come to you for a second. I mean, I opened this conversation by talking about how this report is landing in a moment where there's a focus on economic security and sort of reimagining American manufacturing and reindustrialization. I mean, what specific opportunities do you see biomanufacturing offer for American economic security, and how do you see it intersecting with this current moment of trade uncertainty?
That's a very good question. Thanks, Vivek. So I think bio really does give American manufacturing an opportunity to revive, right? For 2 reasons. One is feedstocks. We have tremendous amounts of feedstocks. We have 1 billion tons of agricultural waste, forest trimmings, and other materials that can be converted to useful products. And we also have niche feedstocks that can really tether manufacturing to the US. An example I can give you is, I live in California, so I'm familiar with California examples. 80% of world's almonds are produced in California. So if we figure out how to convert almond hulls and shells to useful products, yeah, there's going to be 20% that is going to benefit elsewhere, but most of it will be in the US. right? So bio gives that opportunity. And the other part to bio, which is very different from traditional, can you hear me? Yeah. Okay. Different from traditional chemical industry is the catalyst is a living catalyst, right? Like in the chemical industry, you put a catalyst in, take it out, 6 months later, clean it up, put it back in, it works. Whereas in our case, the catalyst mutates away from producing a molecule or reacts to certain feedstock. So you really need the science and scientists, R&D, and manufacturing to work together. That gives another reason to have scale-up and manufacturing within the US and reduce those supply chain dependencies that we currently have. So I really think bio gives the opportunity to deal with some of the turbulence we are seeing right now.
And just to follow up, Deepti, sometimes when we talk about biomanufacturing, we say, okay, we're going to use these feedstocks to produce new products with biomanufacturing, but sometimes we don't get more specific. And when it comes to educating policymakers and the public about the opportunities of biomanufacturing, like you mentioned, almond husks, right? I mean, what can you actually do with that in a bioreactor? Yeah,
so by itself, almond, just picking up that example, almond husks could be recalcitrant to immediate conversion to products. But we've done some studies where we blended some of these recalcitrant feedstocks with more amenable ones like coxflower and other feedstocks. Excuse me. So what we've learned is even by adding a little bit of these amenable feedstocks, like 20% of it, we've been able to reduce that inhibition threshold that exists in these recalcitrant feedstocks. So what I really the point I want to make is there is some scientific work that needs to be done. And we call it at the ABPDU and at Berkeley Lab, we call it the science of scale-up. We really have to address some of these scale-up challenges from a scientific point of view. And if we did do that, if we did spend the time doing that, we have opportunities to convert a lot of these different feedstocks, either biologically or ways to products that we can use in the real world. Yeah.
Great. Thanks, Deepti. Edward, I want to come back to you. I appreciated you being blunt earlier about the state of American biomanufacturing actually maybe being bleak, to use your word. And there's been a lot of talk generally about, we're going to restore American manufacturing, we're going to reindustrialize the heartland, going back many, many, many years, but we haven't really seen progress. And, this report envisions a pretty rosy, actually, maybe you don't agree, in terms of realizing the promise of biomanufacturing as a catalyst for reindustrialization generally.
I think it's interesting that we're on this panel where we're talking about biomanufacturing, primarily referring to bioindustrials. And we're all dealing with bioindustrials. This is not a pharma panel. I do believe that the future can be really bright. And I think that the key strength of the U.S. in biomanufacturing, specifically in bioindustrials, is natural resources. U.S. produces immense amounts of corn, which is the first generation feedstock preferred by most microorganisms. And we have millions of acres of corn. There are 24 million acres of cropland in Illinois, 12.5 million acres in Indiana. And that corn is not going anywhere. This is something that we can leverage to build up natural strengths. In the same way that U.S. built up a gigantic, well-functioning petrochemical infrastructure or petrochemical complex, leveraging the fact that U.S. has oil. And we built a phenomenally powerful technology industry, leveraging the fact that we have great institutions and excellent human resources. I think that the promise of biotech is combining these strengths, is combining the strengths of U.S. geography and nature and natural resources, and combining the strengths of the human resources the country has. 40 years ago, maybe more than half of the largest companies in the U.S. were oil companies. Right now it's technology companies. I foresee a future where in 30 years it will be biotechnology companies or biomanufacturing giants that will produce over 60% of the world's materials. That's a very bright future, and this is an opportunity that U.S. needs to pursue, and it's an opportunity that is U.S. is to lose.
Yeah.
And we didn't come here to lose. We're absolutely here to win.
I think that's a good point. Please, Robert.
Yeah, and I think on reinvigorating the heartland, and at LanzaTech, we have a commercial facility and industrial pilot in Georgia, where it's been a great partnership. Biotechnology is fundamentally different than traditional petrochemical technologies, platforms, in that you can have very high selectivity to a single product. When you do that, you can get away from traditional supply chains. You do not need billions or tens of billions or hundreds of billions of dollars of scale to be efficient and deliver your product to market. You don't have the same complexity of downstream operations. And what that means is that you can be economical and site your facilities anywhere in the country. And so we're able to have a sustainable aviation fuel plant in Georgia that doesn't have to be coupled to the petrochemical industry and a $10 billion refinery.
Yeah.
So that lets you think about how do you site facilities that are closer to the end market, site facilities that are closer to the workforce base or the feedstock.
Yeah. I mean, at a very simple level, it's almost how do we, biomanufacturing is essentially about how do we make the essential things that we need with the abundant resources that we have.
Right.
And if you understand it as simply as that, the potential is quite vast. And it's not just about pharmaceuticals, as you mentioned, but all the other things that you and Edward and Deepti have talked about. And Robert, just to follow up on a point you made about how you guys have cited facilities in Georgia and Illinois. I mean, a lot of the talk around biotech in the report and from people in this room is that historically, when we think about technology breakthroughs in American tech leadership and the economic opportunities that it creates, it's a bi-coastal conversation, and there's a worry that, okay, it's just going to employ more people in, Boston and Cambridge and Silicon Valley and maybe some, the Research Triangle. But there's talk about biotech creating jobs across the country, and can you say a little bit more about that as someone who's actually doing the work?
I think chemical engineering and manufacturing is different. Chicago is a huge hub for manufacturing, chemical engineering, oil and gas. Houston is another great example of that. And so when we relocated our company to the US, we said, hey, how can we find an intersection of great engineers who know how to scale, who have delivered commercial scale solutions their entire lives. And so Chicago was a great place to do that. And we also hire a number of people out of Houston as well. So for us, and I guess the other point is if you're an emerging company, Chicago is a lower cost of living. You can stretch your dollars a lot further, getting away from the coast. So the discount rate on those investor dollars is very high.
Yeah, great.
But I think you also want to be close to the commercial partnerships, closer to the manufacturing sites that you're going to envision. And so if your feedstocks, if your partnerships, if your workforce is not based in the coast, I think there's an opportunity to look at it differently. And the oil and gas industry has some great minds and great experience, and we can leverage that same workforce, we can leverage that same infrastructure. So I don't see that hasn't been our lived experience, that you have to be on the coast. And I think sometimes, getting away, being in a different geographic location, you can avoid groupthink, and you can chart your own path.
We don't know anything about groupthink in Washington, D.C., Robert. I don't know. But does anybody else want to come in on the question of talent? I mean, when you're hiring researchers or employees at LanzaTech, I mean, are there specific headwinds that you're facing that you think illustrate broader challenges for biomanufacturing when it comes to talent? Or are you not having issues? That'd be useful.
I think there are a lot of people who grow up in the Midwest that want to stay in the Midwest, and they're really excited to work in a biotechnology company in the Midwest.
Yeah.
And we also find that people are really excited to be able to have an impact from research to delivering products to the market. And so being a company at commercial scale producing products, being able to give people that diversity of experiences is a big pull.
Great. Deepti, I wanted to come to you. I mean, because you work in the research setting, can you give us a sense of what scientific bioinnovation is needed to secure a U.S. advantage and a manufacturing advantage and sustain it for many, many years, not just in the short term. And this is true for bioinnovation specifically, but also it's not just in the scientific domain, but I think there's a broader question about how do we maintain our innovative edge for manufacturing.
So that's a very good question. So when we think about manufacturing, typically the sense I get is people think that technologies are very mature. The reality is there are very high risk, high reward, fundamental research opportunities in manufacturing that we can design to give US the advantage. So I talked about the feedstock problem before. Another example I'll give you is we collaborated with a group at UC Berkeley to be able to use quantum sensing to understand what goes on at the internal level of a cell in bioreactors, right? So that's not a very mature area, at the very least, that I can say. It took us 2.5 years to transition a lateral flow assay-based quantum sensing to a droplet-based technology so we can connect to the bioreactors. It is sometimes a little bit difficult to communicate this to our different agencies, but I was very encouraged to see the report recognizing the opportunities that exist, because some of these opportunities are not just about bio, it's also about AI. When we think about AI right now, especially in manufacturing, if we need lots of data to have good models, we are always going to be at a disadvantage because it will cost a lot less to generate that kind of data elsewhere. But if we can generate higher quality data, like the ones we're trying to generate with quantum sensing, and now we can have the edge in being able to generate better models, right? More predictive models. That's the kind of work that we need to do towards manufacturing and give ourselves an advantage in manufacturing.
Robert, we were talking a little bit backstage about how the report identifies AI as one of the drivers of American biotech leadership. I was hoping we could maybe drill down a little bit on how are you seeing AI manifest today and how it could be applied in the future for biomanufacturing specifically.
Thanks. There's been great wins already in terms of discovery and lab-based progress, and where there are really good models, and AI has been really impactful in cutting down research time, finding new ways of doing things. I think where the opportunity has yet to be realized is around manufacturing. I think today, historically, we have very narrow data sets. We collect a lot of data points of 5 different things instead of hundreds of different data points needed to train these models and leverage the real capabilities. If you want to run a distillation column, with just a couple parameters, AI can do that very well. If you want AI to run a bioreactor, it's not as good as a highly trained scientist or engineer because of just the wealth of data, the background knowledge. We just don't have that available to put into these AI models.
I would add one thing. AI is, of course, extremely important, and it's changing all industries, and biotechnology and biomanufacturing is not an exception. We are doing a lot of design work without taking manufacturing into account. And I think that one of the things that needs to change and where we can leverage AI is in designing for manufacturing. Leveraging data to take it back to the labs and to bring in engineers and engineering services, engineering mindset into the lab work earlier in the process so that we can be better in bringing these new molecules and new microorganisms to market faster.
And Edward, let me follow up with you for one of our final questions here is, beyond, the United States obviously has a massive advantage in AI, and that if we think about the many advantages that we have when it comes to biomanufacturing, that's one of them. But are there other things you would add to that list in terms of attributes that would give the United States the advantage for biomanufacturing, like an enduring advantage?
Well, I think I mentioned the enduring advantage of just the natural position of the U.S., but we shouldn't take it for granted because feedstocks may and will change.
Mm-hmm. And China has lots of feedstocks.
And China has lots of, and they're genetically modifying corn to make better feedstock and to actually pick up on the advantages that the U.S. has and catch up. I would say just competitive advantages for a country are probably very similar as competitive advantages for a company. And you can't build moats that last forever. Your only moat is constant innovation. And the US has been great at that and needs to continue to be great at constant innovation in support of our science. And in terms of biotechnology and biomanufacturing, it is developing that literacy at earlier stages. It's better teaching biology in schools. And not biology maybe as a separate discipline, but biology integrated into other disciplines. We have high school students that are graduating that have no idea how life works, that have no idea how photosynthesis works. And that's really shameful. So bioliteracy, I think, is a very important component of building a strong biomanufacturing infrastructure. And then, of course, we need to build physical infrastructure, and we need to build it in the right way. We've been building facilities that are single purpose, and they're losing value. Lots of them are just millions and millions of bricks in the ground. They've been built for a single purpose process, and then someone undercuts them on price, and the facilities shutter. Yeah. So we need to build multi-purpose facilities which are designed in the right way, engineered in the right way, constructed to attract third-party capital, and ultimately able to switch when the demand switch production in the same way that data centers do that with different technologies.
Great. I think you've underscored a broader point, which is an opportunity and a challenge, is that biotech, like a lot of other emerging technologies, is going to require a much more cross-cutting and interdisciplinary approach, whether it's at the K through 12 level, the higher education level, and the federal policy level. And that's not something that this town or a lot of our institutions have the muscle memory of doing, but if you actually want to lean into this moment, it's going to be what's required. So in the 45 seconds that we have left, I want to do something really quickly. Maybe each of you identify, there's so many terrific recommendations in this report. Is there one recommendation you want to underscore, and maybe one quickly, a thing you wish had been in the report, but that is not in there? So let's keep it brief before we get the big hook. Yeah.
Sure. I'll say that even within the U.S., we need to maintain competition. I think competition in the marketplace, what drives innovation, keeps costs down. So we should not pick winners and losers. Focus on the outcomes and not how it's achieved.
Okay, great.
Yeah, my recommendation, what I would add, is to emphasize incentives for companies to adopt bioproducts. Because ultimately, the government can be the catalyst for action, but it will be the markets that actually drive getting these bioproducts onto the shelves, onto consumers' tables, into our cars, clothes, and other products that we use. So it's creating the system of sticks and carrots that actually works for these bioproducts to be adopted, and for this promise of the great reformulation to actually become true.
Great. Excellent. Last word.
I would say that the report, as comprehensive as it is still very modest in describing what bio will do for us in the future, and the ask is also very modest, I must say, primarily because even tech industry, they're explaining the costs associated with AI by pointing to the gains in healthcare, right? So it is not like the tech industry, it will be the tech industry of the future. It is not like the space race, it is the space race of the future. So I think we really need to be mindful, and I appreciate the stewardship of NSEB, no criticism there, but we need to be mindful that there is going to be a lot more that we need to cover to be able to be successful, and also time, definitely running out of time.
Great.
It's also a very well-written report.
Yes.
It's actually hundreds of pages of text that can be read, like a thriller.
That's a think tanker's dream.
I want more reports like that.
All right, well, speaking of running out of time, we have run out of time, and I want to thank our panelists. If everybody can join us in giving them a round of applause. Appreciate it. Thank you for making the time. Appreciate it.